All right, I think we can get started. Today we will talk about the aggregative self-supervised learning for medical image classification. So here's a brief overview of this approach. It is published in MICCAI 2022. First about the innovations. This approach uses multiple tasks for pre-training, and the expectation is we can learn better generalization and representation by using multiple tasks. Besides, it also uses a rule for selecting these proxy tasks for pre-training. Another way is that is proposed in this approach in this paper is to train the model in a self-complemental way. We will talk about it later. The first limitation of this approach is its performance on the proxy task is pretty low. For example, the accuracy on the proxy task pools is about 85, and the performance on the downstream classification task is also pretty low. For example, for the 2D image classification, it achieves accuracy of 81.69. For 3D classification, it achieves accuracy of 98.52. The intuition behind this approach is that each proxy task can help the model to learn one type of invariance. When we use multiple tasks for pre-training, we expect the model to learn different types of invariants, and these different invariances can be very helpful for downstream tasks such as classification. First, let's talk about the system architecture under the training protocol. So the basic setup is we have so this is for the pre-training part. Okay, so once the model is trained using the pre-training tasks, then that model will be used for fine-tuning on top of the target class, target task. So here, for example, we have a proxy task like a pre-training task P, and we have a feature backbone phi, and then we have a corresponding proxy task head HP. So in the pre-training process, we will try to optimize the model to get a feature extraction backbone and like a task head that can perform very good on top of this proxy task. And the fine-tuning process, we will replace the task head by the target task head. But we will keep the feature backbone the same as in the pre-training process. But we will use the initialization that is, but we are using the initialization from the pre-trained model in the pre-training task. And in this process, we will fine-tune first the feature backbone and the target task head. And the model will be finally evaluated on top of the target, in the target task. So for the aggregative self-supervised learning, the basic setup is we have a set of proxy tasks, and we call it like candidate proxy tasks. And our goal is to select from first a set of like a very typical, very informative proxy tasks from these task pools to form our aggregated task pool. Basically, this aggregate task pool is a subset of these candidate proxy tasks. So how can we do that? It's very simple. For example, we will use one feature extraction backbone. This feature extraction backbone will be combined with a task head for each of these proxy tasks, and to train this feature backbone and the proxy task head. That means for each task, we will have a pre-trained backbone and a corresponding proxy task head. So for all these different tasks for the corresponding backbones, especially for the backbones, we will fine-tune these different backbones with the downstream tasks by replacing the proxy task corresponding response proxy task by the target task head. And then we will, once we finish the fine-tuning all these backbones, we will evaluate each of these backbone on top in the target task. And we will get the corresponding evaluation metrics. Based on these evaluation metrics, we then select from these candidate proxy tasks, those very meaningful, very useful proxy tasks, so that we can get this aggregated task pool. The key rule is we select the proxy task according to its evaluation metrics in the target task for the corresponding backbone. Another thing we need to pay attention to is about the correlation between these different tasks. We don't want the multiple tasks to learn the same thing, so we have like a correlation matrix to be considered when we select those models. So suppose we get all these proxy, like aggregated task pools, basically a subset of these proxy tasks. Then we will use this set of proxy tasks to train a new backbone. Basically, this new backbone has the same architecture as the previous backbones, but it has different initializations. It's not initialized from the pre-trained feature backbone. And for this new feature backbone and the set of task pool, then we fine-tune this model with the feature extraction backbone and the proxy task head simultaneously on top of this, basically simultaneously in these proxy tasks. Now, once we finish the training of this part, we will use the feature extraction backbone here for fine-tuning in the downstream target task. Yeah. So once the fine-tuning is ready, we just evaluate the performance in the target task using this feature extraction backbone and the target task head HT here. So that is the first approach the authors propose for this aggregative self-supervised learning. Another approach proposed in this paper is this self-complement aggregative self-supervised learning. This approach is very similar to the previous one, but there is a slight difference. This approach consists of 3 steps. In the first step, we use an arbitrary proxy task and a backbone, and also a feature extraction, like a feature, a feature extraction backbone here and a proxy task head here. We first train this feature extraction backbone and this proxy task head. So once this training is ready, we just keep this feature backbone and keep it fixed. In the second step, we will use the same proxy task and also another feature extraction backbone. This feature extraction backbone has the same architecture as the previous pre-trained feature extraction backbone, but its initialization is not from the pre-trained feature extraction backbone. So in the second step, the training will consist of just tuning this new feature extraction backbone and the new new proxy task head. So how can we combine the information learned in the first step? So the key thing is this complement loss. Basically, it's a distance. You can treat it as a regularization of this new representation, and this regularization encourages the model to learn a new representation that is less correlated with that is not correlated with the feature extraction backbone learned in the first step. So basically, here's the loss function. This self-supervised learning loss is exactly the same as the regular self-supervised learning loss, and the difference is just the second part. It considers first the feature learned from the previous feature learned from the first step, and also the feature representation learned in the second step. And in the new training process, the new model is expected to learn a feature that is very different from the previous round of representation. Okay. So about the intuition. So basically, for the first round of training, we actually assume this model can overfit to the proxy task. When we introduce this second round of training, we expect that this model can be less overfit into the proxy task, so that we can get a better representation for better generalization in the downstream task. Now, once this self-complements aggregative self-supervised learning training is ready, basically step 1, step 2, when they are done, we just do the transform learning on top of the second step. We just use the feature extraction backbone in the second step, and we add a target task head, and we fine-tune it on top using the target task data set. So once the fine-tuning is ready, we just do the evaluation as we do regularly for this target task. About the performance, from what I feel, the performance of this approach on in the proxy tasks is not very good. For example, here, in the first step, we just train. Okay, this is the aggregated self-supervised learning approach. Because the first one, we train the backbone for each of these proxy tasks in the pre-training process, and then we do the evaluation on these proxy tasks. As you can see that we, for example, here the highest accuracy achieved is 79, and it is achieved by this SRC proxy task. That means we will select this SRC proxy task to be in the aggregated proxy pool, and then we consider the rest of the proxy tasks. We can see that this same CLR achieved the second highest not the second highest, no, is SRM-CLI achieved the not the second highest, but they achieved the smallest similarity with the already selected proxy task. Then we just add this proxy task to the proxy task pool. That means we have 2 proxy tasks here now. And as you can see that when we add this new proxy task to the proxy task pool, we can improve the accuracy a little bit. But for now here, this is the classification performance of the model in the downstream target task. For example, here is the second, the 2D image classification task, and this is for the 3D image classification task. As you can see that the highest this self-aggregative self-supervised learning approach can achieve is 81.69, and for the 3D classification, the highest it can achieve is 89.58. Yeah, so from these tables, we can see it only achieves very marginal improvement over the existing state-of-the-art performance, and also the performance is still pretty low. Okay, that's all. Thanks.